Welcome to example number 1. This is an example regarding the principle of superposition. We have two waves that are approaching each other here, both traveling at 1 meters per second. This wave is moving to the right at 1 meters per second, and this wave is moving here to the left at 1 meters per second. And what we're asked to do is to draw out the snapshots of the graphs when they're vertically stacked on top of one another, superimposed, at t equals 1 second, 2 seconds, and 3 seconds. And here I've drawn what would happen as both the waves emerge unchanged at t equals 4 seconds. So to do this kind of problem, what you need to do is look at each wave traveling individually by themselves. And then what you do is you move each of these waves to the right or to the left, and then you look at what happens to each point along the space. So like what would happen here at point 2 as this wave moves to the left, and what happens at 3 and number 4 and so forth, and look at the individual displacements as it's moving through here. So I'm going to maybe you could try it first on your own. Why don't you take a moment and see if you can draw out t equals 1, 2, and 3 seconds, and then I'll maybe just pause the video and see if you come up with the same idea that I have here. And to make it a little easier for you to see my solution here now is I'm going to make this wave here and draw this out in red. So just so that you can distinguish here, this is, we'll call that the first wave. And the other wave, I'm going to draw that out in blue here so that you can just sort of see that they are different here. So each of these waves travel at 1 meter per second, so this means this wave will move 1 meter over to the right at t equals 1 second, and this will move 1 meter over to the left. So what I'm going to do is draw each of these waves 1 meter to the right or 1 meter to the left based on this axis here. And so there's the picture of this moved over 1 meter, and so now in black I'm just going to outline what the final y1 wave is. Now I get to here, now start to overlap the red and the blue, but the blue part here is still at 0, so it's really not doing anything. So the final wave is still where the red wave would be. Then when we get to 3, adding these two still will give you right here this blue wave, and then going along here. And so this is what the wave would look like. And maybe I'll erase these two little bits in red and blue here now. So there's t equals 1 second. Now let's proceed on to t equals 2 seconds. And what we need to do is, again, I would look at each of the two waves individually and draw them out. So there's the two waves superimposed on top of one another. And what we need to do is look at the net displacement of these two waves and look at it sort of point by point. So maybe take a look at right here, and then here, and then here, and so forth. So for example, if you were to look at this point midway between 2 and 3, or right at 3, let's go 2 to 3 here, you'll see that the blue wave is about this high, and the red wave is just about this high. So by the principle of linear superposition, the final wave would be the sum of y1 and y2, and you would have a point about this high right here. Let's say if you look at point 3 here, you could see the blue wave would be this high, and the red wave would be exactly the same height as well. And the resultant wave would be about basically double that height. So it would be all the way up to here. So hopefully you're getting the idea what's happening here. So we can see the wave is coming along here. And at this point, the red wave, the blue wave is just really the blue wave here. So it just jumps up to here. And then you get this kind of little sloping line that way. And then sloping all the way down here. And then like this. And that's your final wave right there. And we'll then erase all the little pieces of red and blue here. And there we go. Now take a look at t equals 3 seconds. Why don't you try doing that? Pause the video and see if you can get that. So proceed with each wave moving 1 meter to the right or to the left respectively, and draw the final wave that you get in black. So there's the two individual waves. And now I'll trace out the net displacement that looks something like this. When you get to this point, right at this 3 meters, then it starts to slope upwards up to here. And then it jumps down like that, and then goes like that. So this is your final wave there. And then I'll just erase these individual waves in here. So that's what your picture should look like for t equals 3 seconds, and then there's t equals 4 seconds. Now they're no longer interfering with each other, they're just moving, continuing to move onwards in the direction that they were going. And that's it for example number 1. You can see these kind of examples come up in the multiple choice section of the exam.